Okay. Give online, can you hear me? Is the screen okay?
Yes, sir.
Okay. All right. So the mic start the sound for the next minute here. From the last time, someone told me that this mic was okay. But this I know, I keep forgetting. All right, guys. So we're getting to the more critical stage of the program now. So this weekend is Easter weekend. Next week is Easter. We have to ramp up the work. We're going to try and engage every single day going forward, especially during the Easter break. All right. I want us to do a revision on Saturday, separate and apart from the mock exam. So Saturday is going to be a very important. One, we're doing the mock exam as normal. Two, starting the FBA. And three, we want to start with a topic by topic revision. We start our mini marathon session. So it's like, for example, maybe like at about 5 o'clock on Saturday, I would have a session where we are just focusing on one topic, which is transformation. We decide vectors. We have to see just one topic. You guys can send out in the group a vote of which topics you want me to look at. Put them in order of priority. Right? Based on that now, I will go by those topics. We'll have one session on each of those topics. We'll spend like maybe 3-4 hours just under one topic. Remember, cover the basics and just doing the questions on that one topic. Part after part. And we'll have another session another day. And so we want to maximize the time in the Easter break. Want to pick a day or two in the Easter break as well. We can come and spend the whole day. Then, and we can do the 2 mock exams physically here. You get me? You have to put in the work and want the results. We can do 2 mock exams, 2 full papers, or maybe even 3 full papers here. We want to do that a number of times. All right? More work you do, easier the exam will be. More papers you do, easier the exam will be. We're going to come on stage soon. We're going to be asking for 70% and 80%. And we meet them all 70%. So the grades that we're setting now, they're attainable for the 5%. But those grades not won't allow you to pass the exam and get the grades, the kind of grades that you want. For the 5%. These are those stepping stone grades. For you to make your mistakes, learn from your mistakes, and to be improving from paper to paper. You get me? So, we have to start look to transition now. We put ourselves in the position to start working towards the ones under the field. You get me? We're not going to take the multiple choice for granted. And the multiple choice is like about 30% of your final grade. We want that full 30%. All right. Good deal. Right, guys. So, this kind of a ramp up, right? ramp up, step up the ante, start increase the volume of work. As I said, nothing less than 58 out of 60 is good enough for the multiple choice. That's what we're up to. 58 out of 60 higher. If you have a good SBA, a good multiple choice, you're more than halfway there to pass in the exam. That means that by the time they do the normal questions and exam paper, along with almost maximum, you're really supposed to get the maximum marks in the SBA. You really want to get maximum marks in the multiple choice. Those two papers, you're almost 60% of your final grade already. Those two papers alone. And so with a good turnout in the paper two, that is how we get the ones with the history. You get me? So we're not going to take the multiple choice for granted. Have limited control over the play that you say you go at school, hopefully you get very good grades. Nothing less than 18 over 20. If you get less than 18 over 20, go give it them. Nobody wants to get less than 18 out of 20. Students who do SBA means straight 20 out of 20 me given. Straight 20 out of 20 for SBA. As a teacher, I make sure that the students do 20 out of 20 work. So produce a 20 out of 20 SBA. That's why I operate in my program. I want to go in the exam with maximum marks possible. You get me? All right, so that is it, guys. So, coming week is going to be very, very important. I want to have a high volume of work in the coming week. When I'm telling you, come here, spend the whole day, and nobody start ball and all something. I'm saying we have the 3 past papers in a one day. Nobody start ball and something. Price of beauty, eh? Price of beauty. Oh, Lord. You must be see finished product where you done, take a picture and send to me here. When it done, you want to see. So you take a picture of the before and after from here. The before, the during, and the after. Okay? All right. All right, let's go, guys. Let's do this. Let's do this. All right, so this was the paper that we did. Pass mark is still only 45%. Remember now, I'm going to give one assessment today. I'm not going to know get an assessment today. An assessment, remember, is the test how well you are not repeating mistakes. That's what the assessment is about, you know. How well we are not repeating mistakes. That's what it's all about. That's why we're doing all this work ahead of the exam. So we discover the mistakes and we don't repeat them. One way to not repeat mistakes is for the questions that you get wrong, especially you redo them after I do them. I see the right way it is to be done. I come and explain the right way for it to be done. Discover your mistakes, you learn from them, and you focus on not repeating the mistakes. If you have to do the same question 3, 4, 5 times until you're comfortable with it, that's what you do. Any question CSEC ever set before, and all the papers that we do, let it be that if CSEC said any question like it, or make the mistake and repeat it, let it be that you will conquer that question. It don't make no sense to get exposed to those questions, and then a question like that come on the exam paper and give you a problem. You have to conquer those questions from now. Get me? Conquer those questions from now. That's why I would say, for example, the multiple choice, you work at 100% system. That's if you repeat a lot of the multiple choice questions all the time. And we don't repeat them verbatim to make minor changes to them. So we need to understand the question. And not just know the answer. So we repeat the questions and answers will be different. Sometimes the same answers are there, but the answer is different if and then making a minor change in the question. So we look forward for those things. You get me? So we have to ensure that we order the multiple choice again, we work for 100%. All right. Enough talking. Let's go. First question. Question says, you never say use a calculator, but it's 2023 paper. You must calculate the exact value of this. Because remember, series a calculator, I'm going to show them some steps. I'm going to show them 2 marks. I'm going to show them some steps. I'm going to show them, so we know that we have to work on the multiplication years of first, right? Let's show them that we know that. We have to work on the multiplication years of first. And let's do that. So even though we're using the calculator, we want them to know, so we know we have to do the multiplication first. So we're going to do that. All right? So we're going to add these 2 and work out this multiplication inside there, so by itself. All right. So what does this become? This is 5 over 6. This can become a denominator of 6 as well. So I'm going to write 5 over 6 plus, to get that denominator of 6 here, I multiply it by 2. And I multiply the numerator also by 2. Just to show some work, because I don't know what's used calculator. So this fraction will become 4 over 6. So these two have the same denominator now, so them can add to 9 over 6. Minus, I work out what this is. We can work out that what that is by simplifying or putting on the calculator. Let's say we simplify. Can we simplify? 7 to this is 1. 7 to that is 5. 3 into this is 3. 3 into this is 4. That result is 4 over 15. 4 over 15. I don't like to cross on the work. I'm going to move these. This becomes 4 over 15. 4 over 15. Great. Then this becomes 9 over 6 minus 4 over 15. I put that in a calculator now. I'm having 9 over 6 minus 4 over 15. The paper say can get calculator. Why not? And that took me to 1.23 repeated. I'm getting 37 over 30. I'm just going to double check and make sure. 37 over 30. Just to make sure, I'm going to take the time and put this in the calculator. Just to make sure. So it's 5 over 6 plus 2/3 minus, that's 12 over 35 times 7 over 9. Same thing, so we're good to go with that one. All right, 2 months. Get this one says calculate this value and give the answer to 3 decimal places. So clearly gonna put that in the calculator. And put in the calculator exactly as it appears there. So it's a square root of 1 minus bracket plus 37 close bracket, square that. That's all I know. I'm getting 0.601815 and so on. 3 decimal places. These are your 3 decimal places that you need to correct. This 8 will increase this by 1. So the 3 decimal places will become 0.602. This is your answer, right? And this. Gotta go to that so far. 2 more marks for that. Next question. Write this in standard form. Now look here. When you say the number is so small, you know that the power is always 10 to the minus something. When the number is so small. When the number big, like if it was 527, you know, so the number is 10 to the positive something. All right. Now, in standard form, what we know is that in standard form, the decimal point needs to be right. You have 1 non-zero digit before the decimal point in standard form. Multiply by 10 to some power. So I'm saying, okay, we're going to adjust this number. We want this decimal point to move 3 places to the right. How do we get to move 3 places to the right? We multiply by 10 cubed, all right? 0.00527. To move the decimal point where I want it, I'm going to multiply by 10 cubed. This will move it for me. Cancel back that multiplication by 10 cubed. I'm also going to multiply by 10 to the minus 2. So these and this cancel each other. But this will move the decimal point from it and put where it's supposed to go. But then the final result becomes 5.27 for this we move the decimal point 3 places to the right here times this 10 to the minus 3. And that is the answer. You have to calculate the exam, put this in it and tell it to give you scientific notation. All right. Next question. What mark for that? 1 mark. Good. All right. Let's reduce it. This question says, Haresh works at a call center for 35 hours each week. He is paid an hourly rate of $11.20. Every hour I'm working gets $11.20. That is the regular work. Remember, working 35 hours, this amount of hours. Let's calculate the amount of money he earns in 4 weeks. 4 times the weekly amount. It's simply going to be equal to 4 times the weekly amount. The weekly amount is 35 hours times the hourly rate. $11.20. We're not complicating it. But understand that 4 weeks, and this is the weekly rate. It's 4 weeks. The weekly rate is 35 hours times the hourly rate. That's for the week, and it's 4 weeks a month. So this calculation will give you what it is. So let's break it down. It becomes 4 times. What is the weekly amount? The weekly amount is 35 times 11.2. The weekly amount is 390. You don't want to do the weekly amount first, then multiply by 4. That's what you have to multiply by 4. Multiply this by 4. So he earns $1,563 in 4 weeks, regular work. Right? It says in a certain week, he works 8 hours overtime. That's 8 hours more than the 35 hours in a certain week. Remember, this is the weekly work, weekly amount. Remember that this is the weekly pay. Right? And he's now working 8 hours overtime. Overtime hours are paid at time and a half, 1.5. So basically 1.5 times this rate, 11.20 is the overtime rate. The overtime rate per hour is 1.5 times this. That's the overtime rate. All right. Question says, see there, of this same amount. It says the total amount you earned for that week. All right, you can write one expression. So the total that he's going to earn equal to the regular amount for the week plus the overtime amount. Overtime. The regular amount for the week worked out of it is 392. So you can put that to yourself. 392. What is the overtime for 8 hours? 8 hours times the overtime rate. Overtime rate is 1.5 times the regular rate. You know, 8 hours times overtime rate, which is 1.5 times the regular rate of 11.20. So what's the name? But understand the calculator? This is the overtime rate, and he did that for 8 hours. That's the total he's earning in that week. So the total is in the calculator will get the answer. Not going to complicate it. So it's 392 plus 8 times 1.5, 1.5 is the same as 1.5 times the hourly rate of 11.20. So he's earning in that week a total of 526. You know, the 0.4 is money. So we put 40 as his money. Money must always express 2 decimal places for the same. But go to that. All right, but get that right. Good. Get the question right. Don't get the grad work them over. And not live not complicated and accept these people all the time, time and half, consumer, payroll question all the time. All right? It's not complicated. All right, my boy. Good. Okay, two things I'm going to go to my dad. And go for the go to the top board. Yeah. You and your sister. Yeah, I'm make the mother happy. I don't know if I'm going to appear it happy. This one, simplify this. And the multiplication. So this can just be cancelled down, right? Just cancel down. Divide on the like terms. I like prep school something, you know. The extra cancel the x there. Then 4 into this goes 1 time and 4 into this goes 4 times. And then 5 into this goes 1 time and 5 into that goes 3 times. Notice. Because 1 times 3 is 3 and 1 times 4 is 4. I don't like to mark up. Someone take these. Nobody saw me get that, right? Good. Nice and easy. Next question. Let's go back for this. This question wants us to solve this. Solve means to make M the subject. I always say solving something simple like this is the same steps if you're solving with an equal sign. This one. We're solving this with the equal sign. Same steps. The only difference with the inequality, remember, is that if you do it away, where there comes a point where you have to divide or multiply with a negative number, you have to remember to refer the inequality sign. That's the only thing with this one, you know. It's basically transposing to make M the subject. So grouping all the M on one side and everything else on the other side. They can make M alone the subject, all right? They can decide if we're going to group the N on this side, or you might decide to group the M on this side. Your choice. Let's do both ways. See what happens. All right. So in this first example, I'm going to group the M over onto the left side. And take this 12 and carry it over there. So look what's going to happen. This minus 8M is going to come over here and become a positive 8M. This minus 4M is staying there. Sign stays less than because I never multiply or divide anything. Then no, this 5 stays 5. And this 12 goes over here and becomes a negative 12. So far so good. So far so good. Then this 8M minus 4M is 4M. Less than or equal to this is negative 7. 5 minus 12 is negative 7. Then I just divide by the 4. I'm dividing with a positive number, so I don't need to reverse it back. Divide by the 4 now. And leave the sign the same because I'm dividing with a positive number. So I get M less than or equal to negative 7 over 4. That's it. I could have done it where I grouped the M on the right side instead of onto this side. So I'm leaving this M over here and take this one and carry it over there. So let's see what would happen. So this 12 is on the left side, it stays on the left side. 12. This 5, I'm going to bring it over here and subtract it. I get minus 5. Sign stays less than or equal to, I never multiply or divide anything. This minus 8M is over there. I'm going to leave it as minus 8M. Then this minus 4M goes over, becomes a positive 4M. I get plus 4M. Then 12 minus 5 here is 7. Less than or equal to. So minus 8M plus 8M becomes negative 4M. Negative 4M. To make M alone on that side, I now need to divide away the negative 4. This is a situation number for divide with a negative number. So I'm going to divide both sides by negative 4. But because now I'm dividing with a negative number, I have to remember to reverse that less than or equal to sign, or it remains. Right? So we divide this time by the negative 4, it becomes 7 over negative 4, same as negative 7 over 4. Right here. This sign has to be reversed, greater than or equal. When I divide it by negative 4, just leave it to that end. So if we read this inequality from the right side to the left, we say the m is less than this value. The same answer we got the first time. But all right, i.e., that is, i.e., the m is less than or equal to negative 7 over 4. The same answer we got. That is what. What a good. Let's continue. Part C. I don't think I need to calculate. Part C says the diagram below shows a compound shape. LMNPQR made from two rectangles. So one can divide it here, so I can divide it here so to get the two rectangles, right? It says the length in the diagram, which the length in the diagram, which are written in terms of x, are in centimeters. So all these are the lengths given and they're in centimeters. All right. Question says, find an expression in terms of x for the length of PQ. That's right here. PQ. Let's look at it. Everything is pure for now. So this side is straight. Everything up here is straight. So this is x plus 3. Right? This is x plus 3. So the overall thing is straight. And up here says x plus 3. Then down as a more with 3x minus x. But for that, use that right here, the PQ equal to 3x minus x plus 3 in bracket. So the overall 3x minus the x plus 3 there gives us that. It's not complicated. So it becomes equal to 3x minus x is 2x. And be careful now, it is minus this 3. It becomes 2x minus 3. So this side is 2x minus 3. I'm going to write it on it from now. This side is 2x minus 3. The next thing I want us to find is RQ, which is this length. We're going to find it a similar way. But the total length across here is the same as this up here, so 4 minus 5x. And this length right here is x plus 1. So right here, so with x plus 1. So this piece that you want is equal to the whole of this 4 minus 5 minus this x plus 1. Simple as that. But I go to that, so it is equal to the whole length across, which is 4x minus 5 minus this length right here, which is x plus 1 in the bracket. You're subtracting the whole x plus 1. So we can be careful with these things. So it's 4x minus x. That gives us 3x. Watch this now. Negative 5 minus 1. Negative 5 minus 1 gives a negative 6. This is negative 6. What I got at that? 3x minus 6. So this length right here, so it's 3x minus 6. That length is 3x minus 6. All right? So we have those two dimensions. Let's continue. Question says, given that the total area of the shape is this, show that this equation is the result. So to do this, we need to get an expression for the total area and put it equal 414. That's how this expression goes. Get an expression for the total area, put it equal 414. And the way you simplify it is going to become this. That's how the expressions are used. So what's an expression for the total area? We need to divide it up. Divide up the rectangle. Is that going to divide it across here? And write that area here plus that area here. Or you can divide it up here, so. And write that area here plus that area here. You want to do it that way, yeah? I'll have it on the screen. Don't matter how you do it. So area 1 is going to be this length times this length. And area 2 is going to be this length times this length. If I leave it like this, right? So, and that total area is 4, it is 414. Let's check it. So I want to say area 1 plus area 2 equals 414. Let's try what area 1 is again. Area 1 is the product of these two. We're looking in this rectangle, right? So it is this length times this length. X plus 3, 3x minus 6. X plus 3, 3x minus 6. X plus 3, 3x minus 6. That's area 1. Plus area 2 now of here. Area 2 over here. This length, that's the overall length times this width, which is x plus 1. So it becomes 3x times x plus 1. 3x times x plus 1. It becomes 3x times x plus 1. That's area 1 plus area 2. They tell us it is equal to 414. Expand that total and simplify it now. We're going to end up with this. All right? Let's expand this part first. First term times first term is 3x squared. I'll do the math like big people. The middle term is the far product and the near product added together. The near product is 9x, the far product is minus 6x. 9x minus 6x is 3x, so the middle term is 3x in that expansion. So I'm going to put plus 3x. Let's check it. Yes, plus 3x. Then the last term is the product of this and this. 3 and the minus 6. That gives me negative 18. That's what we get from this expansion right here. And this expansion becomes simply 3x squared plus 3x. And that's all equal to 414. But because I have 0 on the right side, I can take this 414 and bring it over here. So I put minus 414 equals 0. What good at that? We're going to consolidate the like terms and then simplify. What are the like terms? This and this are like terms. Then add up to 6x squared. We get 6x squared. Then the terms in x, this one and this one, will give me 6x. And we take 6x from those two. And then this and this. In the negative amount. 18 and 414. 414 and 18. What's that? That will be 2 and 1, 3, 431. 432. Equals 0. Don't forget this thing here, so now, divide by 6. Divide by 6. Divide by 6. Divide by 6. And you get the equation the one. Divided by 6, we get x squared. Divided by 6, we get x. Divided by 6, you get 72 equals 0. Very good. But all right. Therefore, true. That's what it's about. Yeah. Right? Remember, I could have added two divide two rectangles this way as well, as I said. And then this area plus this way, right? Your chart. I would do this time, this way, this time. So that is it. Question done. Next question, number 3. This question said diagram below shows a semicircle with a diameter. This is diameter and a semicircle with half of a circle. Remember, diameter subtends 90 degrees at the circumference. We know right away that this angle is 90 degrees. Good to know that, right? So this is a right angle triangle. It says B is a point on the circumference, and then this isosceles, because see, they tell us that those two lengths are the same. But this length over here says also 8.2. So an isosceles right angle triangle. It says, state the geometrical name for the line AB. This line AB. It's a chord, right? 2 points on the circumference, a chord, don't it? It's a chord. A line that joins 2 points on the circumference is a chord. But I can argue with that. It says, find the value of the radius of a circle. So the radius is the distance from the center to the circumference. Anyway you want to find it, good. All you know, you need the distance from the center to the circumference. You can be able to find this length here, so if you want. But this will be a right angle triangle. This would be a radius and this would be a radius. I can find it from this, you know. I can find the diameter. Divided by 2, then that's the radius, don't it? I think that's a quick and easy to do, but the amount of ways to do it. But it's a right angle triangle and it's isosceles. So there is part of the theorem to find this diameter and then divide it by 2, don't it? That's all? I think that's it. I think that's familiar. That's not the only way to do it, but I think that's how we do it. So I'm going to say that the radius is equal to half of AC. And we can use Pythagoras' theorem to find AC. AC becomes the hypotenuse in this triangle. And I'm marking this as 90 degrees for the examiner to see. But angle subtended by diameter is 90 degrees. So I'm just going to calculate it here. Half of, and then AC now, which is the hypotenuse, will be the square root of this side squared plus that side squared using Pythagoras' theorem. 8.2 squared plus 8.2 squared. That gives you the radius when you work. But understand that half the diameter is the radius. That's not the only way to do it. But I think this is a quick enough and easy way to do it. 3 marks, sorry, you know. A nice question for 3 marks. Easy. That's not the only way to do it, guys. So I'm going to write half 0.5 times square root of 8.2 squared plus 8.2 squared. 5.79, call it 5.80. 5.80 if you write it to 3 significant figures and it is in centimeters, right? Everything was in centimeters, yes. So if you do it some other way and get 5.80, it's problem. Still good. I can see several other ways to do this question right now. All right, and that's one of the beauty about trigonometry. Trigonometry questions always have multiple ways to do it. A lot of the time. Multiple different ways to do it. All right, good. Next question. Question says, each interior angle of a regular polygon, this is first quarter. A regular polygon means that all sides are equal, all angles are equal. All sides equal. Because it's regular. All angles equal. The interior angle is 60 degrees. Calculate the number of sides.
I know I put good.
Get the mic, please. Get the mic, please. Calculate the number of sides. So we can call the number of sides 10. And then it can be done in 2 nice ways to do it. You can work it one way where you're working the interior angle, total interior angle of a polygon. The total exterior angle is always 360. Total exterior angle is 360. If it's regular, each of the interior angle is the same, and each of the exterior angle is the same. We also the sum of the interior and the exterior angle is 180 degrees. If each interior angle is 160, then the exterior angle is 20. can do the question in 2 ways. And both ways. Using interior angle. Using total interior angle. Total interior angle is n minus 2 triangles. Total interior angle is n minus 2 triangles. Remember, there are n of them, and each of them is the same. So total interior angle is also equal to 160 times n. Because it's n of them, each of them is 160. You want to write an expression for the total interior angle 2 ways and equate them. So n minus 2 times 180, that will always be the total interior angle of any polygon, is equal to, for this one, it is equal to 160 times n. Because it has n angles and each of them is 160. So you can start this equation and you're finding the number of sides. Good. So expand this, we want to get 180n minus 360 equals 160n transpose. So over the 160n here, so we get 180n minus 160n equal to that 360 carried over here, so we get 360. I'm going to show you something interesting, but the same thing to work here. This becomes 20n equals 360. 20 divided by 360 divided by 20 is 18. So n equals 18. So it has 18 sides. The other way might actually be shorter to do. And we know that the total exterior angle is 60. And if the interior angle is 20, if each interior angle is 40 times 160, then each exterior angle is 20. Using exterior angle method. Exterior angle is equal to 180 degrees minus 160 degrees, 20 degrees. Total exterior angle is always 360 degrees. But the total exterior angle is going to be n times 20 degrees. Because n of them, each of them is 20 degrees. That total exterior angle is equal to the 360 degrees total. Yes, you get the same equation. So to find n inverse of divided by the 20. So n it might actually be 50. So it's a good thing to remember that. Two good things to remember in this lesson. The total interior angle is always equal to this. N minus 2 times 180. I said n minus 2 triangles with any number of sides. Total exterior angle is always equal to 360. Regardless of the number of sides. Total exterior angle of a polygon is always 360. Always 360. So that's what we do. Because this is the regular, each of the angles. You see it. And we got all the pictures. Each of the angles in this case is 20. We call it n sides, it's n angles. And that's it. But I go to that. But I go to you know, just something like them and then see them put their point of all right. I like to set question like it's going to be like. This one, cancel me. The diagram below shows a trapezium A drawn on a square grid. So that's a trapezium A. Right? We're going to ask us to do some transformation. It says, on the diagram above, draw the image of A after it undergoes, firstly, a reflection line x equal minus 1, label it A prime. So we're going to reflect that in the line x equal minus 1. So show that mirror line first and then reflect the triangle in it, 1 point at a time. X equal minus 1. It's minus 1 here. Remember that x equal minus 1 is a vertical line. We can remember that the y-axis is x equals 0. X equal minus 1 must be vertical like the y-axis. Just have to pass through negative 1. These things are supposed to be getting consistently low. Now, I'm not speaking stuff like that anymore. So this is the line x equal minus 1. Vertical line passing through -1. Everywhere on this line, the x is equal to -1. Reflecting this image. Let's do it in blue. Let's do it 1 point at a time. This point first. 1, 2, 3 to the mirror line. You're gonna go 1, 2, 3 on the other side to here. This point is 1, 2, 3, 4 to the mirror line. It's gonna go 1, 2, 3, 4 on the other side to here. This point is right below this one. So it's gonna go right below the far one over here so as well. Make sense? Over here. This one. 1, 2, 3, 4. 1, 2, 3, 4. That's it. And this point now is 1, 2. 1, 2 to the mirror line. It's gonna go 1, 2 on the other side just here. And once you have your points in place, then you draw your shape. I don't like when people try to draw the image of a reflection in one go. I would tend to make mistakes and draw the wrong thing. I want to prefer your practice to do 1 point at a time and get the image that way. Be safe. All right? So just use your ruler now and just draw the shape to these points. Don't be 300 like me. Use the ruler, please. And then supposed to leave it right. But good at that. Beautiful. Next question. They want us to do a translation. Remember, translation, you gotta move it. This is translation matrix. This 4 means 4 to the right. This 7 means -7 means 7 down. -7, and this is a 4. We're gonna move each point 4 to the right, 7 down. Now with translation, you can generally just move 1 point first and then drop at the same shape around that 1 point. That's how we're now going to translate. I know this is the same shape, right? You don't have to bother do all the points. Move 1 point, drop at the same shape around that. Then this side we're going to be. We got pattern first. Let's say I'm going to use this point as my reference. 4 to the right, 7 down. Count it up. 1, 2, 3, 4, 7 down. 1, 2, 3, 4, 5, 6, 7. So this point is coming to here. I can check it with the numbers later. Because if you add 4 to -3, you're going to go over to 1. And if you subtract 7 from 2, you're going to go down to -5. You can check it with the numbers as well. 4 means that you're adding 4 to the x value here, so. And the -7 means that you're subtracting 7 from the y value right here. So this point is where that is. Draw about the same shape now around that point. The same shape. Let me draw it in blue. But this piece here, so it's 2 units. See there, 2 units. This piece is 2 units up there, so 2 units. This piece at the top is 1 unit, 1 unit. And then this completes the shape. Complete the shape with that diagonal piece right there. So this is my A double prime. But I'm good at that. We can get them question right now, man. Too easy. We're gonna lose marks for them question. All right. Next question. It's done. That's all I wanted to do. What an easy question. We're supposed to have fun on paper here so far enough. Paper is supposed to be nice, supposed to smile all the way through this paper. And 2023, this is a recent exam. So who knows exam are going to fund them same level? Huh? 2024 good too. Yeah, man. Paper them good, man. The real one, 2025 June, I got good. Gonna be great. Gonna come out and sing it soft with a capital T. Let's continue. This question gives us 3 functions, f, g, and 8. What do you want us to do with them? First part says, for what value if f of x undefined? Another way we could have said this is what value cannot be in the domain of f? What value of x cannot be in the domain of f? What value of x cannot work on the function? It's the value of x that will make the denominator equal 0. Okay, you cannot divide by 0. The function becomes undefined when the denominator is 0. So you don't want the denominator to become 0. And so you don't want the denominator, you don't want the x to be negative 2. But I see that. So it is undefined, it is undefined, it becomes undefined when the x plus 2 becomes equal to 0, which is when the x equals negative 2. So negative 2 cannot be a value in the domain. You get me? This function can't work if x is negative 2. Because it will cause it to be undefined. It can't work out no value. It can't produce no under. It can't divide by 2. You get me? Next part. The one g of a quarter means that we're going to take the quarter and plug it in the g function right here. That's simply going to become 4 times a quarter minus 5. 4 times a quarter is 1. 1 minus 5 is negative 4. Easy. But we're going to do that. Beautiful. Next one. H of negative 3. The question is easy. Take the negative 3 and plug it in the h over here, so. Remember, when you square a negative value, it becomes positive. If you square a positive value, it becomes positive. Any value you square becomes positive. Any real number you square becomes positive. All right? So when I plug the negative 3 in there, so it's going to become negative 3 squared plus 1. The negative 3 squared becomes 9 plus 1. 9 and 1 is 10. Answer is 10. But good? All right. Then this no one, f of f. Remember what f is again. F is what? F was 3 over x plus 2. Write it here, sir. It's on the screen. F is 3 over x plus 2. Now remember, this f of f could have been f squared. It could have given instead same as f squared of 0. They could have asked for that. The same as this. F of 0 means you're going to find the f of 0 first. So this becomes equal to f of 0 first. F of 0 means that you plug in 0 in the f function right there. So it becomes 3 over 2. So you're working out f of 3 over 2. But that's not when we get 3 over 2. We plug the 0 in here, so. So the f of 0 becomes 3 over 2. We plug the 0 right there. So. And now we're working on f of 3 over 2. So we're going to put the 3 over 2 right here. No. So this becomes equal to, well, let us space. I put it right here. This is 0 over. This becomes equal. So we're putting the 3 over 2 right here now. So we get 3 over 3 over 2 plus 2. That's what we're working on now. But let's get answer that. Now, to simplify this quickly, we can multiply the numerator by 2 and multiply the denominator by 2. I just plug it in the calculator. This calculator becomes a 6. This and a here, so becomes a 3 plus 4. Because 2 times this give me 3. 2 times this 2 give me 4. So it's 6 over 6. Let's go again. It becomes 3 plus 4. So 6 over 7 is the answer. No? 6 over 7. I'm getting 6 over 7, man. Somebody got that? Oh, they're right then. Thanks. 6 over 7. Very good. All right. Let's continue. Next question, I want us to find g of h. G of h, remember, it means h into the g. Let's write them down. What is the g and what is the h again? The g is equal to what? What is it again? Write them up and copy them down. G is 4x minus 5, and the H is x squared plus 1. Remove them down. Paste them under here. So to do this now, we put in the H into the G where the X is right here. That's how we put, hold on, it's contagious. That's how we put G into H. That's how we put, sorry, H into G. That's what we have to do. We put H into G. That's a construct of it. So we can write now, G of H of X becomes 4 times, where this X is I'm putting the X squared plus 1 where the X was. And then subtract by the 5. But I go to that. And then simplify this now again. 4x squared plus 4 minus 5. 4 minus 5 is negative 1. There's 4x squared minus 1. Nice. But I write that. Good. Then they want g to the minus 1 of negative 2. Then we do 2 ways. You can find g to the minus 1 of x first and then plug in the negative 2. Or we can make g to the minus 1 of negative 2 equals some value and find the value, some unknown value and find the value. Let's do it the 2. The method 1. We're going to find g to the minus 1 of x first. That's the method we're using first. You want to say p equals, inverse it, g becomes x, and the x becomes g to the minus 1 minus 5. And we're trying to make this a subject. If you over the 5, it becomes x plus 5, divided under the 4. That is g to the minus 1. This is g to the minus 1 of x now. You have to put in back the of x now. And so since we want g to the minus 1 of negative 2, we're going to plug the negative 2 in there somewhere. We can say, therefore, g to the minus 1 of negative 2 from negative 2 plus 5 over 4. The negative 2 right now. That becomes 2 over 4. The other method is to put g to the minus 1 of negative 2 equals some number. That's our method. And when we find the end, we have the answer. So if g to the minus 1 of negative 2 equals n, it means that negative 2 is equal to g of n. Like to transpose the inverse on this side. G of n now means I'll put it n in the g function right here. It means that minus 2 is equal to 4n minus 5. Same transposition you have to do to find the n. If over the 5 and divide by the 4. If you over the 5 and make it positive, it becomes 5 minus 2 divided under the 4. That is the n. This will go to 3. 5 minus 2 is 3. So the n again is 3 over 4. So g to the minus 1 of x minus negative 2. So that's a order question though. But all right. Online, everybody good? People online quiet, so.
Yes.
Yeah. All right. Just so you know. So all right. We'll now go on. All right. No problem. Next question. Number 5, statistics. Number 5 says, each of 75 girls, it's important to know, 75 girls, can't forget. Each of 75 girls recorded the name of their favorite sport. The number of girls who chose track and cricket are shown in the bar chart below. All right, they give us a bar chart, you know. All right, so let's mark those numbers on top. Let's read the scale and mark those numbers. So basically then, this should have been 2, don't it? It should have been 6, it should have been 10, it should have been 14, it should be 18, right? And for example, right here should have been 17, halfway between the 16 and the 18. It should have been 17. All right. So this one on top here is clearly 12. So put the 12 on there. Let's put them on top here. So it's right in front of us. This one is halfway between the 16 and the 17 and 18. So this is 17. So we have those numbers. Number of girls who like cricket is 17. Number of girls who like track is 12. That's what the question says. The question says, how many more girls choose cricket than track? That's 5. 17 minus 12. Cricket and track. That's 17 minus 12. That's 5 girls. 5 girls more. Like cricket and track. 11 girls. 11. Remember them important. Make a note of them. 11 girls recorded. 11 girls recorded tennis as their favorite sport. All right. Tennis is 11, right? So I'm not dry team from now. I'm going to more take a dry team. Tennis is 11 up here, so. See 11 right here, so. Right here, so. Let's just put in the tennis from now. I know they're going to ask you the dry team. That's how these questions are. The most asked to complete the bar chart. The shade. That's 11. So far, I got 17, 12, and 11 girls, right? All right. The 11 girls choose tennis. It says for the remaining girls, that's the girls for swimming and football. Those are the remaining girls, right? The number who chose swimming compared to the number who chose football is in the ratio of 2 to 3. The remaining girls for those two sports from the 75 girls is in the ratio of 2 to 3, swimming to football. And they're going to want us to use information to complete the bar chart. To complete the bar chart, we need to find out how many like swimming and how many like football. And we know that the remaining is in the ratio of 2 to 3. So what is the remainder? What is the remaining? What is that? How much is remaining? How much? 25 remaining? 35? 75 minus what we have already. We have 11, 12, and 17, don't it? I think what 35 for 2. 35. All right. So swimming, let's make sure. Swimming to football to the remaining is 2 to 3. Remaining part is 5. So the actual remaining part is really 35. So for the ratio to the actual, we need the remaining part to be 35. But the multiply this ratio by 7 to get this part to become 35. When that part becomes 35, then we will have the actual number. Multiply this by 7 to get 21. Multiply this by 7 to get 14. 14 and 21. I don't know why. Right? So let's go ahead. Swimming. 14. Football. Let's draw those bars. 2 minutes. Another one going up to 21. There's 21 on this. It's right here, so it's right here, so the 22. 21 is on this line. Right in between here, 21. All right, so that last bar coming up today, right here. Football is the most popular sport. More people, 21. 21. And that's your bar chart. It said determine the mode of sport. The sport with the highest number of people is football, don't it? Football. Let's write football right here. Mode of sport is football. That's it. One mark for that. It says one girl is selected at random. By 75 girls. One girl is selected at random. What is the probability that she chose neither track nor cricket? This is to choose the race. That's what that means, you know. There's 75 girls total. Let's work it out. Track was how many again? Track and cricket was what again? Track and cricket was 12 and 17. 12 and 17. So the probability of not track nor cricket, the rest of them, right? The rest of them, which is 75 minus 17 and 12, divided by the total of students, 75. That's a probability. That gives you the probability. The rest of them you want, which is 75 minus the people who do cricket and but understand that working out. The rest of them you want. You don't want, it says neither track nor cricket. So you say you want nobody else. The probability of getting everybody else is the number of other persons that you have divided by 75. Or if you wanted, you could add up these. You could add up these. These are the other three, you could add them up. That's the other way to do it. That's the other you want. You could add up those three and put over 75. Same and take them again. So, what's your report? Huh? Over 75? 46 over 75. So if you add up these three, you're going to get 46. This plus this plus this. It's also 46. All right? That's it. Next one says, the information on the favorite sport of the 75 girls is to be shown on a pie chart. Here in the sector of football. The fraction of the girls that is in football of the 360 degrees. But the total in the pie chart is 360. Football was 21. Over total 75 girls. That's a fraction that the football girls represent of the total girls. They want that as a fraction of the 360 degrees in the pie chart. That's what they're working on. What are you working on? Huh? 108, 100.8, 100.8 degrees. Thank you very much. Wow, that's beautiful. Making life easy for me. Thank you. All right, better go to that. But all right. Remember, if you never get it right, go and do it. If you never do it, go and do it. You do it by yourself. You do it. But are the foolishness enough? You have to do them over. Here. The more papers you do before the real exam, the easier the real exam is gonna be. Work the questions, do the papers, do the full papers. Not one question today, one question tomorrow. Do full papers. The more time you do the full papers, is the easier doing the full paper on exam day is gonna be. I promise you. You're gonna come out the exam smiling and other people crying. Don't be one of the ones crying on the exam day. Come out the exam happy and smiling. Happy before and happy after. You're happy before because you have confidence that you're ready. But you get to gain the confidence and you gain the readiness by doing this work. Come on, man, don't shortchange yourself. Next question. That's a special question because I don't set this very often. The net of a code. Easy stuff. You like it after this. You set one again, you conquer it. Question says, in this question, take pi r squared over 7, and the bottom of a code is this. 1/3 pi r squared h, where r is the radius and h is the height. Right? The diagram below shows a sector OMRN of a circle, center O and the radius is 12. The sector angle inside is 168 degrees. All right, so it's formed using a thin sheet of metal, right? So this is the net of the cone, you know, the net when the cone is flat out. That's what when you have a three-dimensional object, when you flat it out, that's what they call the net. Flat out, right? Or it looks like it's flat out, and you fold it into the shape that you want. So this is the net of a cone in this question. Question says, calculate the perimeter of the sector above. So the perimeter, remember this is also 12 over here, so let's put it on. This is also 12. That's a radius. So the perimeter is 12 plus the 12 plus the arc length. So you need the arc length down there. Remember the arc length is a fraction of the circumference. Fraction is taken as the sector angle over 360. The circumference is 2 pi r. All right? That's what this arc length is. Fraction of 2 pi r. So the perimeter here that I want is equal to 12 plus 12. That's these two sides. Plus the r is 168 over 360 times 2 pi r. This is the arc. This right here is the arc. That's the formula for the arc. Fraction of the circumference. And the r right here is 12. Let's put the 12 there. Let's put the 12 right here. Oh, Mr. Short. 12. Let me shift it down and write the formula above it. So the arc length right here is theta over 360 times 2 pi r times the circumference. That's what this is. Put all that in the calculator. But understand that this is circumference of that shape. But understand the circumference is the distance around the shape, right?
Yes, sir.
Good. Let's work it out. So 12 plus 12 plus 58 over 360 times 2 times pi, that's supposed to take pi 20 over 7 times, and the radius is 12. Huh? 158, so let me calculate that 158. It's 59.2. 59.2 centimeters is the perimeter of that thing. What good? All right. Let's continue. Question says, a cone is made from the sector. The sector is the net of a cone. By joining OM to ON, as shown below. So what they do is that they take this as the vertex, and this vertex becomes this up here. And so it's like you pull this up, like this thing is flat, and you pull this up towards the middle, And then these two ends go on and join one another. And that's where you get the cone. That's where you get the cone. So let me draw it right here. For the cone, you get the cone. Cone is formed. Like this. What it is that, you see, this curved part becomes the base, circular base of the cone. This arc piece becomes the circular base of the cone. You see, right, when you join this over to this and join it, so this becomes up, this comes up here. So this is the O up the top here. This is the O up the top. Then this point and this point, they join together and they are now beside each other here. M and N join together. So this arc is now the whole circumference. So what is the length of this arc? Is now the circumference of the base. Right? And then now this length is now this length. Right? From O to M. There, you know, this line is right here. Right? So around it, let's see it. This length is now this length. This is now 12 centimeters. And this circumference is what the arc length was. So this circumference equals the arc length. The circumference of this base is now equal to the arc length over there. But I understand that. Understand that?
Yes, sir.
You can visualize it. But the flat thing, and you pull this middle up towards in the middle. Pull it upwards. When you pull it upwards, then these two ends, they go around and they join together to form this circular base. And then this piece goes up in the middle right here. Then this length, these two lengths, they join one another here. They join one another right here. Join together right here. So that's why you get the cone. All right? We're going to after it, we're going to say over it. That's what you're going to do here. All right, so that's what we have. You have realized that the arc length is the circumference of the base, and then this length is this slant length of it. That's what you have to realize. Let me see the diagram down here. So see, you know that this length is 12 centimeters. And the same OM from the original diagram. See the OM. Same OM that from the original diagram. OM. All right. And then the arc length is the circumference. This circumference equals arc length. That's what happens. Just as I can get the radius of the cone. To get the radius of the base of the cone, that's what I have to equate. The circumference of the base is now the arc length. Let's put that right here, sir. So we're using this information right here to answer this. The circumference of the base a while ago, which was 2 pi. The big R up here we're using. This big R up here. The circumference, the arc length. Or 2 pi R, circumference of the base. 2 pi R. 2 pi smaller. 2 pi R. 2 pi R. That's the cone circumference of the base. Equal the arc length. And the arc length was 168 over 360 times 2 pi times 12. We'll try to find this R now. But understand that? You guys understand that? I have a quick note here. Circumference is equal to the arc length. Circumference of the base of the cone is equal to the arc length of the sector. Circumference of the base of the cone is what the arc length of the sector was. So this is the circumference of the base of the cone, 2 pi R. This is the arc length of the sector. I tried to find the R from this. So we need to divide by the 2 pi. So we can cancel 2 pi from this side and from this side. So 2 pi. So the R is equal to the product this times this. Whatever that works out to know is the R. So the R equals this times this 12. Here, 168 over 360 times 12, 5.6. That becomes the radius. Anybody got that? Anybody got that? Good. They don't want the height of the cone. So this length across here now is 5.6. And this slant piece is 12. That's a right angle triangle. The part of us is still going to give us this H now. Anybody see that? Good. Right? So the H that we want down here is going to be the square root of 12 squared minus R squared. Remember, 12 is the hypotenuse in it. The square root of 12 squared minus R squared in Pythagoras theorem. The R is 5.6. You put those values in. So the square root of 12 squared minus 5.6 squared. You they don't give you a lot of space to work these things. And so it's just space small. To the space small. They don't expect a lot of work to get these answers. Square root of 12 squared minus 5.6 squared. That's the height is 10.6 centimeters using 3 significant figure. That's it. 12 squared minus 5.6 squared. That is it. But good. You need to go and rewrite this question if you can get it. You need to go one again. You know what's coming on your exam paper. All right. Next one says, calculate the capacity of a cone in liters. Now, to get to the liters, you have to know 1,000 cm cube is the same as 1 liter. That's what we have to know. 1,000 cm cube is a liter. Because you're going to calculate in cm cube first because all dimensions are in cm cube. So remember that the volume of a cone is 1/3 pi r squared h, right? So it's 1/3, the pi is 22/7. The r is 5.6 squared, and the height that we just got was 10.6, right? Yeah, 10.6. That's going to give you the volume in cm cube. If you wrote that out, so 1/3 times 5, which is 22/7, times 5.6 squared times 10.6. So that's 328.5 centimeters cubed. To get the liter, we divide by 1,000. That's right. One up to the 0.6. That is 348.25. To get to the liter, you have to divide by 1,000. That's it there. 1,000 cm cube is a liter. So to go from cm cube to liter, you divide by 1,000. All right, 1/3 pi r squared each. R was 5.6. So divide this by 1,000, we get 0.34825. Divided by 1,000, 1, 2, 3. We get 0.34825. That's it. Any questions on that? What else on that? All right. It's something. Next question. Number 7, pattern question. We have 4 more questions to do. So usually finish in a jiffy. Question says, a sequence of designs made using blackness and whiteness. So the first 3 designs in the sequence are shown below. You can see the pattern. So in the space provided on the grid, we must draw a figure design 4. I don't have to explain it. You can just draw it, right? The design 4 is gonna have one additional black disc up here, so don't you? So we have 4 here, so we're gonna need 5 now, right? 1, 2, 3, 4, 5. Black disc. I'm drawing it blue. We're gonna have a white one on top, right? Like that. Then here you're gonna have 4. You need 1 more. Okay, so to keep increasing. You need 5 again. 1, 2, 3, 4, 5. And all the spaces inside here, you're gonna put white discs. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is the shape of design 4. But I agree with that. That is the shape of design 4, right? 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, that's making sure. All right. Ready for the table. The number of white this W and the number of black this B and the total number of this T that form each design follow a pattern. The values of W, B, and T for the first 3 designs are shown in the table below. Study the pattern of numbers in the table. Complete rows 1, 2, and 3 in the table below. Looking for patterns in the formula, especially if they're adding the same number of values each time. But this one is just a formula, right? So we need to see what the pattern numbers are in this formula. You can see the pattern numbers here, and see here again, and here again. We're going to fill out this line first, as usual. So basically, it is n times n, I'm seeing. N times n. N times n in the bracket. Plus n again. Plus n. It's always plus 1. Plus 1. Equal a final value. I'm going to make that final value be n squared plus n plus 1. That is really n squared. That is. In this column now, always increasing by 2. And the number of black discs always increasing by 2. So I put 1 for the horizontal and 1 for the vertical. So 2n is a part of the formula, right? Increasing by 2. Yeah, but this first figure has 4 in it. 2 times 1 is 2. We have to add 2 to get the first shape. I get the first number in the first shape. This is the formula for this column. And over here now, these are not increasing by any constant value. Because here, increase is 6. And here, increase is, I want that, 7, 8. So it's changing. So we're not going to use no formula. But this is the total disc. So this is the number of white and number of black. To get the total, we can add up these 2 then. Add them. Get me? You got the total. So add them up. So this column right here is the sum of these 2. It is n squared plus n plus 1 plus 2n plus 3. So n squared is the only square term there, sir. N squared. And n plus 2n is 3n. And then 1 and 2 is 3. That becomes the formula for that. All right, ready now. Put in the values. So here where the n is 9 easy. This so we need a 9 here, so. 9 here, so, and a 9 here, so. And a 1 here, so, don't you? 81 plus 9, 90 plus 1 make 91. This is 91. All right. And right here, so now we'll drop the 9 on this formula down here. 2 9s 18. 18 plus 2 is 20. But I give you that. 2 9s 18. 18 plus 2 is 20. Right here is 20. And you check it. Got up to 111. 2. This plus this is 111. 2. You're confident that that is correct. In this line now, this is the pattern number. So we say right is at 20. It's 20. If we get this one now, same thing, you take the 20, just on this formula. 2 times 20 is 40 plus 3 is 42. Then over here is always the sum of these two. Add them. I'll use the formula. Add up these two. So adding up these two will get 4, 6, 3. If I add up this and this, don't you? 4, 6, 3, yeah. Good. And able. Done. Next question, please. Team has 28 black discs and 154 white discs and wants to make design 12. So design 12 knows when the n equals 12. Explain why it is not possible for him to make design 12. So it's going to be not possible if you do have the requisite number of discs for the design. Right? So we have white disc and we have black disc, right? The white disc formula is what? This one. N squared plus n plus 1. N squared plus n. And n is squared, right? And put the n in squared. N equals 12. It becomes 12 squared plus 12 plus 1. What is the work out to? 144 plus 30, don't it? 157 white, because it 157 white. We'll have 154 white. They don't have enough white. See that? That's what he needs. He needs 157 white. Not enough. Do have to calculate the black. Not enough white. Yes, I only have 154. Short by 3. And that's it. We don't have enough black. We don't have to calculate the black. The white, we must have to do already. Let's randomly calculate the black first, the white first. But I've calculated the black first. I think the black was all right in this game. But the white was all right. All right? So that's enough for him not to be able to make it. Better go to that. All right. You need 147 only to make that 150. Do have anything. All right. Next question. Section 2 now. The time is so fast you can do them. Let's quadratics. Remember the quadratic, you can see the symmetry of the values on the table, especially when the x values are in an equal interval across. If they are, the interval is 1 across from value to value. It means then that these y values are going to be symmetrical about symmetry, a line of symmetry. It can be found on the table as well. The values are symmetrical. All right? So let's look at it. We're looking for the symmetry. I'll fill out these, you know. I'm going to use the symmetric nature of this function to help us. So when you repeat value, nah, we're not going to repeat value. So we calculate at least 1. I don't have any repeat value no to see the symmetry. So we calculate at least 1. So let's calculate for 1. Let's calculate for 1. Okay, right here, use an easy value. Y would be minus 1 squared plus 1 plus 7. This is 8 minus 1. 8 minus 1 equals 7, right? Right here, so it's 7. Good knowing. No, I'm not good yet. Kinda, yeah, but kinda good. 7. The 7 go back to 5, so that 7 must go back to 5. You see that? See that? It's 7 go back out. Must go back this way and same way. So this 7 go back to 5. So this one must go back to 5. So that's right, it's a 5. When this 5 go back to 1, so that 5 must go back to 1 as well. 1. Then this one go back to -5, so that one they must go back to -5. So -5. That is it. I only need to calculate 1, then I use the symmetry of the values to get the rest. The values are symmetrical. But understand that. Let's look for. Huh? You have to work out all of them. Huh? What you say? What you say? No, the negative not squaring. The negative is not squaring. You want to square in the x. Negative is not squaring. The square is only on the x here. Square is only on the x. The negative is not squaring. Good. You know this happening here now. -1 squared like that. That -1 squared. The square is only on the 1. Good. All right. All right. And then I'm going to indicate my symmetry on this. You're going to help. So that's a maximum. That's not a maximum. The maximum can only appear at 1 point. So your maximum is your vertex point. Your maximum point is right in between those two, halfway. That's a line of symmetry. You know, that represents the line of symmetry. You know, right between the 0 and the 1. Halfway between 0 and 1 is 0.5. So this is XE. The X value turning point is 0.5. Come on, we'll do this the same thing all the time. All they do is change the values. And we're doing the same thing all the time. Come on. We have to learn to do the mathematics easy. 0.5. Then the Y value at this point, you plug in the 0.5 in this. Right here. The Y value right here. You plug in the 0.5 in the function. You're going to get minus 0.5 squared plus 0.5 plus 7. So the Y is going to be, this is 7.5 minus a quarter. That's 7.25. It's going to be 7.25. It means that your vertex point, the vertex point is the maximum vertex. Oh, no, it's maximum. But the square term is negative. So the maximum point is this X value, 0.5. This Y value, 7.25. You can get it from the table just like that. You don't have to calculate nothing. But the values are symmetrical about that line of symmetry. Just as though it's symmetrical, just as though the function symmetrical on the graph, the values symmetrical in the table. The values are the same outwards from the axis of symmetry. Once these X values are in the same interval between the values, then the Y value is going to be symmetrical from that line of symmetry. The values are symmetrical about this thing. Y values are symmetrical about that. Learn that, man. Only 2 marks for this. You can calculate 1, 2, 3, 4 values. 2 marks. Tell the examiner that the values are symmetrical if you want. Values are symmetrical about the red line, yes? Here the negative, not upon the square, not upon a negative then. The square only upon the X. Negative is not squaring, same thing with the 1. The problem, man, I have to question and learn. Sometimes I have to make it drive it home. The negative is not squaring. The negative is not squaring. It's only the X alone squaring. You see it? If the negative was going to be squared, it will look like this. The negative was going to be squared, that's what it will look. The square is only on the x. So I'm going to stick. So I have to practice. So we get the example, we will say, no, square the one, the negative. Right? The square is only on the x. Square is not on the negative. All right, let's go now. Then you're going to want us to draw the graph. That's what these questions are always going to see. I want you to draw the graph. It says on the grid below, draw the graph between 0 and -3. So now we're plotting the points that I want to table. Right? And it's all of them have a plot. What a wicked question. But we can use the symmetry of the values, you know. But in the other paper, you can look back and forth and plot the points. And the good thing is scale it up for you already. It's kind of easy, but scale it up for you already. But the symmetry is a half, right? Symmetry is a half. Half in this line. Put it in the range. What is our symmetrical about this red line, this line here? X equals a half. That's the axis of symmetry of your graph, right? All right, let's put them in bunches. Let's put them in bunches. Let's put them in multiple at a time. So starting at -3, and the values are -5, 1, and 5. -5, 1, and 5. First three values. -5, 1, and 5. Starting at -3. -5 down here. 1 is the next one. 1 right here. 5 is the next one up here. 5. Those are the first 3 points. -5, 1, and then 5. So these are intervals of -3, then -2, then -1. Good? Next 3. 7, 7, 5, 1. 7, 7, 5, 1. Who's can remember that? 7, 7, 5, 1. 7, 7, 5, 1. And the last one down, you're going to come back down to down stuff. That's symmetrical down stuff. Those are the points. So you have to put in the vertex point. Just I don't give you another table, but you have to put it in. Okay, you cannot draw the graph. I'm just making it come across here, so. But that the graph has a vertex point. This question is testing your knowledge of that. Let's put it on in blue. It was 0.5, 7.25. It's on this red line on the vertex on the axis of symmetry. 7.25, let's estimate it. The right here says 7.5, don't it? 7.525 is about here, don't it? We're talking about somewhere here. That's where the vertex point is, somewhere around here. If he expects you to do that, if you don't do that, you're going to lose marks. So draw the curve because they come up to this point here. So. All right? Make sure it comes up. I mean, at the exam, them ask me, I should put them telling me. I've never seen so. Right. This point, 0.5, 7.25. Make sure them system know. And they draw the smooth curve. Come down on this side. Okay. Let's go again. Getting loud, getting loud. Next slide now. I'm going to draw the best curve that I can to the points, right? Hey, I want to get the Lord. We'll class done it, you know. What's happening here? Stop talking, man. Grade on the paper and tell me what you're going to get. That is it. That's the graph. What else I wanted to do? What else I wanted to do? Because right, see, I don't know what is the maximum minimum point. I'm going to tell him that is maximum. 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 And 0.5, 7.6. Every question asked for it, you know. This one they did. Every question asked for it. The maximum. All right, what else? It says, write down the equation of
Excuse me,
symmetry.
sir. Excuse me, sir.
Yes.
Could you show me about the graph, please?
Okay.
Thank you, sir.
And then one ask of symmetry, that's the red line. X equals 0.5 or x equals half. X equals 0.5 or x equals half. That's the axis of symmetry down here, the one. X equals 0.5. So you say you get these marks quickly because you figured them out from the beginning. Next part. Using your graph, find the solution set for this. Know what that is? That gives you the roots. That's a quadratic equation. This gives you the roots. Root of the x value of the graph, intersect the x-axis. That's what you want. Just have to use the graph. The long way calculate it. Look at the graph and find the root. We're talking about these 2 points. This is one of them. Look at the root. Something like what? X equal negative 2.2. This one is 3.2. X equals 3.2. Got a root. Root. Another root. My question is I use the graph. I'm showing you more I use my graph. Negative 2.2 and 2.2. X equals negative 2.2 and 3.2. Very good. Next one says, on the grid on page 4, draw the line passing through those 2 points and determine the equation of the line. I'm sorry, give some more. Draw the line through these 2 points. -3, -1, and 0, 3. -3, -1, and guys. Here. -3, -1 is here. 0.8 is here. Use the rule and draw a straight line through those 2. Very good. Use a rule and draw a straight line. Bang. Use your rule and draw straight like a touch of curve right there. So. If you draw it on graph paper, you see it, right? It look like a touch of curve right there. That's that green line I want to put on the 2 point. This point is -3, -1, right? And this point is 0.8. You know, join them. -3, -1, and 0.8, and join them with that straight line. Then I want the equation of the line. No. See this? This is a C value enough. This is a C value enough. Y-axis intercept is A. But if you want it to get the gradient, they can count it off. Gradient is the rise over the run between these 2 points. You can actually count it off. We can calculate it still enough. Difference in y, this y value minus this y, this that y value minus that y value. What this x value minus this x, calculate it. So it's 8 minus -1, this y value minus this y value, over this x value to 0 minus this x value to negative. It becomes 9 over 3, which is 3. You can count it off on the graph as well. You can count it off and show it. It becomes 3. You could go on the graph and count it off as well. So it looks like if you draw it to a straight line, you might have these 2 points. These 2 points, this and this. No, not that one. This and this. No, the line of draw. Yeah. This and that is a 1 unit, yes. Yeah. 1 unit between -3 and 3, 1 unit. See there? I use those 2 points. I do it on graph if I see it better. See here from here to here, the rise is 3 units, because vertically every centimeter is a unit. See that? And the run is 1 unit, because on horizontally every 2 centimeters is a unit. So it's rise 1, run 2. They could get the gradient that way. Rise over run is 3. So you get the C. Know that you know the M and the C? That's the equation. The equation is y equals 3x plus 2. That's it. That's the figure of that. That's 3x plus 2. All right. Next question. Number 9. F and R have one circumference. P tangent to the circle R, angle PRL 40 degrees right here, and angle RON is 156 right here. That's the angle at the center. That's the angle between a tangent and tangent to the chord. That equals the angle subtended by the chord right up here, so right now. So I already know that this whole angle is 48 degrees. Let's answer the question. Let's start here. Let's answer it. All right. So everything that they have said so far is on the diagram. It says, find the value of each of the following. Give it reasons for each of your answers. Show all workings were appropriate. The first angle I want is angle R right here. All right. So this angle R, we go back and find what is subtending it. It is being subtended by this red cord. The same cord is subtending 156 at the center. Angle at center is twice angle at circumference. The one at circumference is half 156, right? And I will have center rule. This angle R equal to half of 156. What is that? How much? 78 degrees. Reason. Angle center, angle at center. Twice. In the center. Let's put down there. 28 degrees. This angle is 78 degrees. Which one next? This angle right E is between this chord, this tangent right. We call a tangent and chord rule. So because the angle between tangent and the chord is E, that the chord subtends that same angle at the circumference in this 78 up here. Let me say this is also 78. tangent and chord. But I understand that also called the alternate segment. So E is 78 degrees as well. Angle between tangent and chord equals the angle subtended by the chord. It is also 78 right over here. So I'm going to put it down there. This is 78 degrees. That's right. 78. I don't know if you that's really. This angle is 78. Angle between tangent and a chord equals angle subtended by at the circumference in the alternate segment. Right? This we're going to do that. Next part I want is angle A. Let's look back at this. Angle A. Angle A is over here. So angle A is one of the angles in the cyclic quadrilateral. Going different. That's a cyclic quadrilateral. Right? And this angle A, this angle here, they add up to 180 degrees. Good? These three angles also are up to 180 degrees. It means that this angle is the sum of these two. I can appreciate that. Make sense? Look again. These two angles are up to 180 degrees. And these three angles also add up to 180 degrees. Must mean that this angle is the sum of these three. If you don't want to do that, you could find this one first. And then find this one by doing 180. So this one in here is going to be 180 degrees minus 78 and the 48. Why is that? Somebody can tell me why is that? Why this angle inside here, sir? Is 180 minus 78 and 48. Why? Angles on a straight line. Good. So what is work out? Where this one from? 180 minus with some of those two. One again. But the angle is going to be the sum of these two, you know. So we have to do the same subtraction again. One again. 54. 54 degrees. Angle on a straight line. Is 180 degrees. And then angle A now is going to be, this is now 54 degrees. You know. So angle A right here now is going to be that the A is equal to 180 degrees minus the 54 degrees. It's going to give out the sum of these two. What does that work out for? 180 degrees minus 54 degrees. What's 126? So the A is 126 degrees. Why? Because opposite angles in a cyclic quadrilateral are supplemented. Good? I'm going to write for this one. Opposite angles. Opposite angles in a cyclic quadrilateral are supplementary. And that is it. Opposite angles in a cyclic quadrilateral are supplementary. So this is what you need down at the bottom section there. This is a part of my answer. You know. I'm leaving it on the diagram right there. Put this down here. Right. That's it. Anything else? Nope. Anything else? Next question, please. Next question is a parent's question. Said, diagram below shows a triangular field LMP on horizontal ground. They give us three sides. If you have three sides on a triangle, you want to find an angle, you're going to have to use cosine. Must know that. It says, calculate the value of angle MLP. That's the angle inside here. All right? So the one, this angle inside here. Let's call it phi. Let's call it angle. Cosine rule. Now we're using cosine rule. Treat these like your two sides and start as if this is an hypotenuse. Start out that way, as if that's that angle is an hypotenuse. So you start with cosine. You can imagine cosine rule as if it's part of the beginning. You subtract that. All right? So we're gonna do that. Treat this like a 90 and treat this like a hypotenuse. You basically say this over here for the hypotenuse, you have 180 squared. The hypotenuse equal to the sum of the square of the other two sides. It is the 150 squared plus the 120 squared. If it's not Pythagoras theorem, you have to subtract a piece. Subtract 150 and the 120, the cosine angle between them, which is the phi. That's cosine rule, you know. Cosine rule, you just use. And then you basically now want to find this angle. You have a transpose. And we're supposed to can practice now and see the transposition of this whole thing. Come over this side and become positive. This 180 square come over this side and become negative. Let me do step by step. We're gonna get, see, we got a lot of speed to do it. Let's quickly get fast. We're gonna have 2 times 150 times 120 and the cos of theta equal all of this 150 squared plus 120 squared. Take this and subtract it over here. Minus 150 squared. And all of this product now divide under here. So I'm just gonna move it under there for you. Divide it under here. 2 times 150 times 120. All of that equals that. And then now you take the cos to the minus one of this and the theta as a subject. I'm going to do it right here now. So see the cos theta equals this. We're going to find theta with the inverse cos on this expression. We're going to do it. Come cos to the minus one of all of that. So you have to be able to do this transposition in one step. I say they don't give you a lot of space to be doing a lot of different lines. To do it. The small amount of space they give you. Practice you be able to do it quickly. So you have to practice them. No man practice them. You got to the calculator on it. Okay. I don't know how to find it. You don't have to follow. Sometimes a good way of you can just use a symbol to reference an angle. It's easier. Let's start to the minus one. 50 squared. 20 squared. Minus 150 squared. 82.8 degrees. 82.8 degrees. All right. What else I want us to do? Tells us that the bearing of P from L. Oh, we do the from position. You can note that from L to P. During the student and take what you do is throw the bearing on the diagram, like you want to start the question. So the bearing is at the from position and it's moving on 10 degrees clockwise from L to P. Let's look at it. Let's look at the diagram. L to P, moving on 10. L to P, the bearing is moving on 10. Keep in mind, please, the reason that this is the north line. This is the north line at the from position L. 210 degrees is the bearing down to this direction. That's clockwise coming all the way around here. 210 degrees. But I understand that. But I go to that. Clockwise angle. The north line at the from position. The line that's taking it to the two position. So the vertical line. At angle 210. You take it off and take it off. This angle they tell us is good. You have to put on the diagram to see how it works, right? This angle here is 210 degrees. All of this spread angle. 210 degrees. 210 degrees. So if that angle is 210 degrees, then you can know this angle right here. First. What would this angle be right here? What is that angle right here? It's also a bearing down to M and S. What is that angle called? 210 minus 82.5. The whole thing is 210, and inside here, so it is 2.5. So it's 82.5. Angle inside here now is the other bearing angle. Equal to 210 minus 82.5. Let's go from now, because I might have asked, sorry. Right? 1 foot, 7.2 degrees, right? And after that there is 210 minus 2. That's minus R squared. This is M from so that's what happens. So to be equal to 210 degrees. What do you say, John? 127.2 degrees. Right? Then it says no. Calculate the value of the angle NLP and hence the bearing of L from P. I don't need to know the more. L from P. L. Now you can look at the something like that. But I need this angle to help me find it. Angle NLP. Let's see. NLP. End up here, so NLP. And come inside the answer this point. It's fine. Perfect. Like asking us what is angle. What is the angle equal to? We're going to get that angle. We're going to get that angle. 60 minus 210. But the total angle of the years 210. The whole thing would have been 360. So this piece in here is 360 minus 210. This angle that I asked was here is 360 minus 210 degrees. What is that? Right here, use that. Tell them the bearing from P to L. From P to L. Bearing from P to L, let's call it something up on the diagram. The last question at that was for next question. I don't know. I'm going to call it on the theater. Put them around. So just calculate the angle I want. Put the angle. And then 360 minus 210, which will 60 degrees. Again, I don't want it 30, you know. This angle is still going to call it theta. Right? Call it theta. It's under that. So the bearing of all from L from. So the one from P up to L. You need the north line at the front position, E right here, so. The bearing angle that I want to this one. Clockwise to the line that will take you out to L. That's the angle that I want. Right there. That's the angle I'm calling theta. That's another north. That angle is just 180 minus 150, you know. But these two angles are what we call co-interior angles, don't it? Angles in the U. So that angle theta is 180 minus 150. Right? What's the U that down this parallel line, just then like up the parallel line. These two angles are up to 180 degrees. The bearing angle theta that I want, 180 minus 150. I think only 30 degrees, but because it's bearing, I put the 0 in front. So the theta bearing angle that I want, which is the theta bearing angle that I want, theta is 180 degrees and it's 150 degrees, which is 30 degrees because the bearing don't put 3 degrees at the in front. That is the answer right here. One question to go. What is dying? Nobody will die. One question. Let's go. Let's down for example. Let's start after 5. And it's just 7:30, you know. Exam time is 7, 2 hours. Don't do that. Last question. Let's go. Number 10. Matrices transformation as well. Matrices A and B represent transformation given as this one. That is the anti-clockwise 90 degree rotation matrix. You have to know them on site. See? Anti-clockwise 90 degree rotation about the origin. This one is the y equal minus x reflection. See there? Y equal minus x reflection. Learn them on site. And every question will teach them here like that. Let's determine element of matrix C, which represents the anti-clockwise rotation to the A, followed by the B. That's what I asked you. A followed by B. So A followed by B is B times A. Second one times the first one. The most known is by now. Things like this you don't give away. A followed by B is BA. You multiply the second one by the first one. You multiply them the wrong order, you're going to get the wrong answer. Because multiplication is non-committed. Then multiply the second one in front of the first one. So we're doing 0 minus 1 minus 1, 0. So C equal this amount. So that single transformation is C. Equal BA. And the A is 0 minus 1, 1, 0. So that's what C equal. I multiply them the same way again. The answer right here. So the first value here is this row times this column. First element times first element. Second element times second element. So the 0 times 0 is 0. And negative 1 times 1 is negative 1. This value is negative 1. Answer is going to be 1 down here, 0, 0, you know. That's kind of. Because you know that 2 sections go to 1 rotation. Let's write them. The value over here must be at 0. It is this row times this column. See, it is 0 times this negative 1 and negative 1 times 0. This value is 0. And this value down here is this row and that column. That's a 0 as well. Negative 1 times 0 is 0. And 0 times 1 is still 0. This is also 0. The last value down is going to be a 1. Because if you do the second row, second column, They multiply this second row by the second column to get the negative 1 times negative 1 and positive 1. And 0 times 0 is a positive 1. That's the most know that is the y-axis reflection matrix and side. They ask you for it. That's the answer right there at C. See? Describe geometric transformation C. Reflection in the y-axis. Reflection in the y-axis. So its question is, you get two in them. Tell you what they are. The one that you get from the calculation, they are asking you what it is. You still have to know that. You don't feel them want to give you all of it. This one, you have to know what it is. That's a y-axis reflection matrix. So the first negative one in it. Right? What is that? Been telling you from a long time. You must learn all the matrices. Just see for yourself. Who wants to know that? No one spend the time always to know that. Get down to bed in 2 months. Learn the matrices, guys. Tell me the ones that you must know. Learn them. Next one. It says, transformation T is defined by this 2 by 2 matrix. And it maps this point onto this point. How it works? You apply this matrix to this point, and it is equal to this point. That's what it is. So this is setting up a matrices, an equality of matrices for us. Right? It is the matrix times this point that is equal to this point. It sets it up like a matrix in this case. So it's 1, 2, A negative 1 times the matrix for this point, which is 2, 3. And that we apply this matrix to this point. The result is this point, which is 8, 15. You're calculating the K. If you're calculating the K, you want to use this value. But that value is the product of this row and the column. Get me? We set that up. It means that the K times the 2 is 2K. And the minus 1 times the 3 is minus 3 is equal to that 15. Transpose the 15 and get 18. 18 divided by 2 is 9. So the K is equal to 9. That is it. But understand that? What to go to that? Remember, when you apply a matrix, all the matrix work, and a transformation, you multiply the matrix by the point, and it's going to be equal to the resulting point. That's what we set up right here. And we have an unknown value in the matrix. So know which row multiplied by which column to give it the values. That is it. Next question. Vectors. Nice and easy. Finishing strong. The question says, WX is this vector, XY is that vector, ZY is that vector. Determine each of the following. A vector other than 5, negative 1 that is parallel to WX. A multiple of 5, negative 1. All over. Any multiple of 5, negative 1. So we can write 2 times 5, negative 1. It will be 10, negative 2. You can put any multiple you want. Any multiple of 5, negative 1 will be parallel to 5, negative 1. When vectors are parallel, one is a multiple of the next. You're asking me for a vector. You say, you have to give this answer. So somebody might decide to put 3. Somebody might decide to put 4. Somebody might decide to put 1.5. Any multiplying constant, they just don't want 1. Because 1 going to give the same vector. It's other than this. That is parallel. You could put any multiplying constant in front of you. I'm not using this as an example. This is an example. It could be any multiplying constant. This was an example of what an answer could be. Any multiplying constant. Yeah. Any constant times 5 negative 1. You know, constant is any real number. And any real number. Use any real number. Maybe I got any real number, but I don't want use my start to one. They don't want what, but I don't want it to get back to any real number, not including one. Or I don't want zero either. Not including zero. Not including zero. If you have zero, you don't have a vector, right? But they don't want one, I don't want zero. These are also not equal to right. You get the picture. Any number you want, you would multiply by the vector. You get a vector of expired. All right? Next question. They want WY. In other words, which of these vectors will combine to take it from W to Y? This one starts at W, this one end at Y, and X is the stopping point. See there? That's what vector is at this level, you know, or you get from point to point. So X is like a stopping point. So if you add those two vectors, you're going to get WY. You can say to go from W to Y, you can go W to X with this one, and then go X to Y with this one. Not complicated. So from W to Y, we're going to go W to X first, and then X to Y. So adding those two vectors that we have. WX is 5, -1, and the XY is -7. That's going to give us the answer. 5 and -1 is 2. -1 and 7 is 6. 6. Then the one, you go from X to Z. Start at X and inner part. Start at X. So this one start at X. This one, so this one go from X to Y, right? This one is YZ. This is a rule between Z and Y, you know? That's a rule between X and Y. Just started, I really like this one ending up as Z. It's simple. If this is ZY, we want it to be the other way around. Because you want to go from X to Y, they can go from Y to Z to get the result that you want. But this vector is from Z to Y. You can flip them around and introduce a negative, because the opposite direction in vector Z introduces the negative. And from this one, you flip around this order and put YZ. In order to negate these values, change this to -8, in the opposite direction, change this to 7. So we can combine this one and this one now to get this result. X to Y, Y to Z. Simple as it. And I'm leaving this sum up here. I'm leaving this sum up. I'm leaving this sum up here. Tell the examiner down here. We go from WX to Z. I'm going to go X to Y first, and then Y to Z. And the X to Y is -37. Here, -37. And Y to Z is -87. -8. -8. The final result is -11. 14. That is the answer. Anything else? Yes. We want the modulus of XY. Modulus of XY is the length of XY, length of the vector. Becomes equal to the square root of the square of the component, like Pythagoras' theorem. All right? What is XY again? XY is this, -37. It's just equal to the square root of 3 squared plus 7 squared. Let me explain. So the vector XY is -3, 7. It means that to go from X to Y, got 3 to the left and 7 up. That's what it means, you know. Go from X to Y, you're gonna go 3 to the left and 7 up. We reach Y. This is the vector XY. Okay. That's the vector XY. There are components. 3 to the left, 7. This modulus is asking for the length of this line. Length of that line is 5,000. Give you the length of that line. Now this is the right angle triangle. That's why I can put that the square top. This side square plus that side square. That's why I get this. That's why we can do that. So we don't need to put the negative on it. But the negative 3 squared is the same as 3 squared. 3 is just the length of this dimension. The x is just the negative is just the direction. So the length of the vector. So the length of the vector. Whatever this works out to the answer, guys. That's 49 and 9, don't it? What is that? 7, 49, don't it? And 3 is 9, don't it? So 49 and 9 is the month. 58. Square root of 58 unit as a length. This is a length. Put the word unit. End of this test. And that is that. So everybody must get more than 45. Don't. Huh? And who don't do it, enough to do it. All who don't do it, need to go and do it. Look here. All have another mock exam on Wednesday and on Thursday. Everybody, you have a paper to do on Wednesday, you have a paper to do on Thursday, you have 2 papers to do on Saturday, and that's a Saturday evening, we're gonna have a revision in the night, in the evening. So prepare yourself. Exam preparation start. Hello, mom. Remember, say me before picture, the during picture, and the after picture. Huh? Yeah, what's way up so far? Price of beauty. Oh, by the way, guys, online, everybody good classes over. Everybody's okay online.
Yes, sir.
Yes, sir. Yes, sir.
Remember, practice. Read all the questions you got wrong, okay? Read all the questions you got wrong.
Yes, sir.
Prepare yourself. A lot of work to do before the exam. Prepare yourself. We want the exam to be easy. All right, bye, everybody.
Bye, sir. Wednesday.
Come on. Wednesday and Thursday. Wednesday and Thursday. All right.